Hey boys and girls! Today we're going to learn how to solve one-step equations. So by the end of this, you should be able to solve one-step equations that contain one variable. So we've been working really hard on writing algebraic expressions and using variables to represent numbers. So let's talk about what are one-step equations. One-step equations means that there is only one step in order to solve for the variable. Let me repeat that one more time. A one-step equation means there's only one step that you need to do in order to solve for the variable. So I think you guys can do that. You guys can add, subtract, multiply, and divide, right? Which means that you can solve for one-step equations. What we need to know first are inverse operations. So for adding, the inverse operation is subtracting, and vice versa. For subtracting, my inverse operation is adding. For multiplying, my inverse operation is dividing. And just like that in reverse, because it goes both ways, the inverse operation of dividing is multiplying. You can also think about reciprocals. So if I had a fraction, like 1 over a variable, its reciprocal would just be the variable, or the variable over 1. So inverse and reciprocal are very, very similar. So let's go down here to the practice problems. It says use inverse operations to solve for the variables. Well, let's think if that makes sense. If x plus the amount 10 equals 17, using my fact family knowledge, I then know that 17 minus 10 must equal my unknown value, or x. So basically what you're doing here is you're going to do the inverse operation. In this case, since the operation is addition, your inverse operation is subtraction. You're going to subtract 10 from both sides. You have to do it to both sides because 10 minus 10 equals 0, which means it clears out the left side of my equal sign. Then whatever you do to one side of the equation, you have to do to the other. Just like with fractions, whatever you do to your numerator, you have to do to your denominator, and vice versa. So 17 minus 10 equals 7. Therefore, x equals 7. You can always plug in or substitute your answer. So 7 plus 10 equals 17 to see if they are in fact equal, to see if you got it correct. So we're going to try a few more examples. In this example number 2 over here, I have x minus 2 equals 14. The inverse operation of subtraction is addition. So I'm going to add 2 to both sides. That cancels it out on the left, leaving just your variable x. And now x is equal to 16. I can substitute in 16 minus 2 equals 14, and that is in fact true. So I know that x does equal 16. Looking at example 3, I've got a multiplication problem here. My inverse operation for multiplying is dividing. I'm going to divide both sides by 6. Remember, a number divided by itself equals 1. So having the coefficient of 1 in front of the x just makes it x because of the identity property. So dividing by 6 does in fact cancel out that part of the expression on the left-hand side of the equal sign. X is going to be equal to whatever I get when I divide 12 divided by 6, which equals 2. So now I'm going to use substitution. Is it true that 6 times 2 equals 12? It is true, so I know that I'm correct. In this last example, it looks like a fraction, but don't let that trick you. Remember, the fraction bar represents a division sign. So this is a division problem. So the inverse operation of division is multiplication. That's going to cancel out to be 1 again. Why? Because basically you have 1/4 times 4 over 1, which equals 4 over 4, which simplifies to 1. So again, having the coefficient of 1 in front of the x makes it not necessary. So now I'm going to multiply my other side of my expression by 4 as well. So now I have the expression x equals 8. I'm going to use substitution. Is it true that 8 divided by 4 equals 2? And it is. Therefore, I know I've gotten that one correct as well. It's very important to note to not forget to balance the equations. You must do the same operation on both sides of the equation in order to get the correct answer. I want you to pause the video here now and do the problems that say your turn. After you've done them, you can press play to check your answers. Go ahead and check your answers. Pause the video if needed. Don't forget to reflect on what you learn. Because I'm not going to be there with you on Wednesday, Thursday, and Friday, I really want to make sure that you understand how to solve one-step equations. If you have any questions, please simply comment on Google Classroom, and I will get back to you.